Hello everyone. Today we will talk about a very interesting topic, orbits. But what exactly is an orbit? We will explain everything in this video, focusing on the orbits of objects around the Earth, such as artificial satellites. Part 1. What is an orbit? Imagine shooting a cannonball with a cannon placed on top of a mountain and parallel to the Earth's surface. The cannonball, once it leaves the cannon, will travel a certain distance, and then fall to the ground. Increasing the power of the cannon progressively, the cannonball will travel increasing distances before falling to the ground. Imagine now having no limits to the power of the cannon. We could increase the distance traveled by the cannonball to the point where it completes an entire circular path around the Earth. At this point, the cannonball would be in orbit around the Earth. At even higher speeds, an elliptical orbit is obtained. By increasing even more, a specific speed called escape velocity is reached, at which the cannonball escapes from the Earth's attraction. This is a thought experiment and it cannot be realized for two main reasons. The first is air resistance. The cannonball would have to be launched at such high speeds that it would burn due to friction with the air. The second is that the power required would be so high that a cannon of this type would not be possible. However, moving above the Earth's atmosphere and replacing the cannon with a rocket engine, we can achieve what we want. A rocket basically performs two operations. It transports the payload out of the atmosphere by rising almost vertically, and then rotates and accelerates it to the correct horizontal speed, or rather tangent to the Earth's surface, so that it completes a full orbit around the planet without crashing to the ground. Let's see some definitions. An orbit is the path that a body, such as a planet or an artificial satellite, follows around another body, such as a star or a planet. The force that keeps the body in orbit is the force of gravity. The orbit occurs at distances and speeds such that the centrifugal force, mv²r, equals the gravitational force, gm1 square meter, r squared. Part 2. Orbital parameters. A closed orbit can have a circular or elliptical shape. There are several parameters that describe an orbit, including semi-major axis, r, which is the average distance between the center of the orbiting body and the center of the body around which it orbits. Eccentricity, e, which describes the shape of the orbit, circular, elliptical, hyperbolic. Inclination, I, which describes the angle between the orbit and the reference plane, such as the Earth's equator. Longitude of the ascending node, omega, which describes the position of the intersection between the orbit and the reference plane. Argument of perigee, omega, which describes the position of the closest point of the orbiting body to the body around which it orbits. In summary, an orbit is the path that an object, such as a satellite or planet, follows around another object, such as a star or planet, due to the force of gravity. The shape and parameters of an orbit can be described using various measurements such as the semi-major axis, eccentricity, inclination, and longitude of the ascending node. Furthermore, orbital mechanics is a complex field of study that deals with the motion of objects in space, including how they are affected by various forces such as gravity, thrust, drag, and other perturbations. The study of orbital mechanics is essential for the design, operation, and navigation of spacecrafts. It is also important for understanding the behavior and dynamics of celestial bodies, such as planets, moons, comets, and asteroids. To put a satellite or spacecraft in orbit, it must be launched with enough speed and at the right angle to overcome the force of gravity. Once in orbit, the spacecraft or satellite will continue to travel around the central body, following the path of its orbit. The altitude of the orbit and the speed of the object will determine how long it takes for the object to complete one orbit, known as its orbital period. In conclusion, we hope that you now have a better understanding of what an orbit is and the different parameters that describe it. The study of orbital mechanics is an essential field for the advancement of space exploration and technology. Thank you for watching and we hope you enjoyed this video. If you did, please consider subscribing to our channel, liking this video, and turning on notifications so you don't miss any future content. If you have any questions or suggestions for future topics, please let us know in the comments below. Thanks again, and we'll see you in the next video.